Alright, let's take a look at this review. So these first 6, we're just determining what kind of correlation they have. Okay, so remember, if it's down and to the right, negative, up and to, or down and to the right and down, negative, up and to the right, positive. If it's all over the place, no correlation. And then if they're close together, stronger, further apart is weaker. Okay, so let's start with the no correlation. Number 4 is definitely no correlation. Okay, then positives. Okay, so if I look at number 6, pretty spread out. So yeah, definitely a weak positive here. Okay, 5, with how close this one is definitely a strong positive. And number 3, if I look between 6 and 5, I would say 3 is probably more strong than it is weak, so I'd probably call that a strong positive. Okay, now if we look at the negatives, okay, we've definitely got this one close together, so that's definitely going to be a strong negative. Now, number 1, okay, looks like it's most likely strong. It'd probably need to be a little more spread out like this in order for it to be weak, so I'd probably call that a strong negative as well. Okay, though I understand if you'd call it a weak negative based on how it kind of curves and goes right there. But really, what it comes down to is knowing that correlational coefficient, because if we know the correlational coefficient, then that's going to tell us for sure if it's weak or if it's strong, okay, or no correlation. Which the next 6, 7 through 12, okay, that's what we're trying to guess at, is looking at this graph, can we figure out what that correlational coefficient is? So what that R value would be on all of these. Okay, and remember the trick is it's all on a spectrum. So we go from -1 to -0.5 to 0 to 0.5 to +1. Okay, anything in this zone between 0 and 0.5 is going to be weak, whether it's negative or whether it's positive. Beyond the 0.5 is going to be strong. And if you're at 0 or really close to 0, that's going to be no correlation. So if I look at number 9, probably going to call that no correlation. Now, in all reality, it's probably really like -0.2 or something like that. Okay, so you could put -0.02 or +0.02 or just 0 to represent that no correlation. Okay, now the ones that are the least spread out are going to be the ones closest to 1 and -1. Okay, if I look at 11, it looks closer together than 7, so I'd probably call that like 0.98, probably really high. Whereas 7 maybe would be more like negative because it's going down, 0.90. Okay, maybe even 0.8 something. Okay, then this one's a little weaker, but still pretty strong, so maybe like -0.75. Okay, this one positive again, but still a little weaker, but not a ton weaker, so maybe like 0.78. And number 12 is probably the weakest of all, besides no correlation, so maybe I'd call that like a -0.51. Okay, maybe even 0.45 negative or something like that. Okay, but that's kind of the idea, is looking at those numbers and making a judgment call based off of that. Alright, now constructing a scatter plot, pretty easy, right? We just plot the points. So 0.23 is right here, 0.24 right here, 0.24 again, a second one, 0.34 right here, 0.5 and 6 right there, 0.9 and 10 clear up there. And that's all we got to do. Okay, so number 14, now it's not so easy, right? Because 3 and 0.6 would be like really close down there. Then 28 and 11 would just be slightly higher. 58, 413 would still be pretty low. Like these are all pretty low till we get to that 83, and 7,000 would be slightly higher. 89 and 16 be up here-ish. and 98 and 46 would be clear up here. Now, when it comes to the test, you are actually going to be able to, get an exact points because you won't have to draw it by hand. You'll just be choosing, okay? All right, 15 and 16, though, same idea. 10 and 800, 60 and 500, 70 and 400, 80 and 300 and 400. Oops, not that one in the middle. And 100 and 200. Okay, that one was pretty easy because the numbers all kind of matched up. Whereas if we look at 16, here's another one. So that would be 100. That's not going to match up so much. So 20 and then 104 would be up here somewhere. 190 and 11,000 would be like up here. 290, 2,000, 480, and then these are all like really close to the bottom. 720 and 930. Okay. All right, so that's just drawing the scatter plots. Okay. Now, 17 is what does the residual plot tell you about the line fitted to the data? Okay, 17 and 18. Remember, with the residual plot, that's not the actual scatter plot. Okay, that's just how that line of best fit is. And what we're looking for is something that's more random. Okay, whereas we look at 18, it's definitely got that N shape to it. Okay, that's bad. So what does this tell us? It tells us that that linear function is not a good fit. Okay, you would need some other function. So linear function, not a good fit. Okay, 17, it's more randomized, so it would work. So linear is a good fit. Okay, for that one. That was actually supposed to be an F-I-T. That's better. All right, so that's using those residuals. Okay. Now for the rest, we're going to be using the calculators. One thing to mention, I forgot to put a review question that talked about causation. Just remember that causation, nothing can ever show causation. Okay, we can show a correlation, but we can't show causation with stats. And that should be good enough. Okay, now we're going to use the calculator to help us with these ones. So what I'm going to do is we'll take a look at the calculator, kind of do that, some of this on the calculator, and then bring it back here for this section. Okay? As we start with the calculator, the first thing we want to do is go to New Document. Okay? And we're going to choose Lists and Spreadsheets. Okay? Because the first thing that we need to do is we need to come up with our data. Okay? Calculator doesn't know what data we have going on, so it's up to us to figure out what that data is. And so we take a look at that table, and as we can see, we've got weeks and savings. So I'm going to put weeks here, and then savings in the other column. I should say, not calling. Okay. Then we are going to enter in our numbers. So 1, 3, 4, 7, 10, 13, 20, and then we put in the other side, making sure they match up. With 1 was 200, then 175, 162, 120, 87, 57, and finally 5. Okay, now, a few things to know. If we just leave this cursor like this, or even in the next one with no number, we're not going to be able to do the stuff we need to do, okay, on the calculator. All right, so we need to make sure we hit enter and we have the more highlighted version. Also, if we're hanging up around in here when we try to use the menu, we're not going to be able to, see? Or maybe we will right here, but I think it'll ask us something weird. Let's go with this. So linear regression, right? Let's actually back that up. So menu, statistics. Actually, let's show you when we've got something like this. If I go menu, statistics, see how it's all grayed out? Simply because I left that box like that. Let's try it if we're up here. menu, statistics. Okay, so that seems to be working, though I think there is something it will ask us. So if I do 2 variable statistics, which that's one of my options, so weeks for X and savings for Y, hit OK. Okay, it's going to work. I think if we have X's and Y's in as our labels, then it might throw us some issues. So I go down here and we look for that R variable, okay? So my correlational coefficient is going to be right there. Okay, so I can write that down in the B section. Now I also need to write the equation and draw my scatter plot. So let's create a scatter plot. So Control Doc, we go down to Data and Statistics. But remember, I've got to choose my X variable, which was weeks, and my Y variable, which was savings, and there's my scatter plot. So I sketch that as best I can on that paper, okay, which you should be able to get a pretty decent looking one because I kind of gave you the same window. All right. Then to find that line of best fit, the equation, we hit Menu, go to Analyze, Regression, right, because line of best fit is a regression, and then we want to show that linear mx plus b. And so there's my line of best fit, which I sketch on there, and there is also my equation. Okay, so I write that equation down. Now on part D it says estimate the amount of savings at week 17. So weeks are my x's. So I'm taking this equation here and I'm going to plug in 17 for weeks. So I can do that right on the calculator, or I can do it by hand. So if I hit Control Doc, I can add a calculator, and I don't type in the y equals, okay, we don't want to type in that, but I type in negative 10.4 and then 3 5s. So negative 10.4555 times, because it's multiplied by x, we said week 17, so I hit week 17, okay, and then we are adding 201.774, so plus 201.774, right? Double check to make sure I got it all right. Hit enter. So that's to part D. So the amount of savings we should have at week 17 according to our line of best fit, $24.03. Okay? Which again, I can kind of try to estimate that if I were to look here at 17 on my graph and come up here, but that's kind of hard to estimate looking off to the left. So that's why I think the equation is the better option. Okay? So let's see what that looks like on our paper, and we'll move on. So as we look at this, we found that the correlational coefficient was negative 0.99, which would be a strong negative, wouldn't it? If we needed to write that, we don't, but just letting you know. Okay, I've got my scatter plot up here. See how I graphed it so well? I'm so good at that. And my line of best fit as well. Okay, we also have the equation, which I'll write down here. Negative 10.4555 times x plus 201.774, right? And then we solved it in the calculator, which I could also, solve it by hand because this was x. So the idea here was that we had negative 10.4555 times 17 plus 201.774. And when we did that in the calculator, we ended up with 24.0305, which we could round to 24.03. Okay? Savings, that would be money. Okay, so there we go with that. All right, did all those. Now let's take a look at number 20 and see if we can do the same thing. So in this one, again, we go New Document, Lists and Spreadsheets. Okay, now we've got Depth. So I write D-E-P-T-H, and this is question number 20, by the way, and light. So we enter in our numbers, right? You don't have to do it vertically like that. You could go across, but on these calculators, it's a lot easier if we just go down. Just make sure that things are matching up correctly. We end up with this, okay? Now we need to get our correlational coefficient, so I'm going to hit Menu, down here to Statistics, stat calculations, and we're going to do, let's do linear regression this time. We can do 2 variable or linear regression, and it pretty much works the same way. Okay, our x is depth, go down, our y is light. Okay, then we go down until we hit OK, and then we can scroll down here and we see that there's our correlational coefficient right there. Okay, 0.498, which I could round to 0.5. Okay, so if I'm talking about that one, that could be most likely a weak positive. Okay, almost a strong positive, so it's going to look pretty strong. Which, speaking of, if we go to that control doc to add a page, data and statistics, we can add our depth and our light. Okay, though now that I look at this, I think I was supposed to change something and I didn't. Instead of depth and light, I think that should have said homework and grade. So this actually should have been homework, and I put homework. Okay, homework, and this should have been grade. Okay, oops. Everything else is the same. The numbers were all the same, but this was homework assignments that you turned in, and then your grade in the class. Okay, so let's adjust that again. Homework and grade looks the same though. Okay, so kind of spread out there, isn't it? Okay, so draw that scatter plot as best you can. Okay, numbers look a little bit different, but do the best you can on that. Okay, we found that correlational coefficient, so let's find the line of best fit. We hit regression, show linear. Okay, there's our equation. There's also our line of best fit. So it said, what grade would you receive if you turned in 8 assignments? So we want to take our equation here, and we want to see if x were 8, what that would be. So again, I can add that calculator and just have the calculator do all the hard work for me. So 1.5262, I believe. Yep. Times x. So times our x is 8 assignments. Then we add to that 65.1663. Okay, hit enter. And so our grade should be about 77%. And we could round that to 77.4% if we wanted to. So there we go on our second one. So we got our correlational coefficient of 0.498, which we could round to just 0.5, which again, that would be a weak positive. Okay. Then we draw our scatter plot. And you can see that mine is pretty awesome. Okay, there's our line of best fit, our regression line. Y equals 1.5262x plus 65.1663. And then we found that it was at about 77%, like 0.4, when we turned in 8 assignments, which we used that by taking the 8, plugging it into x, and solving. Okay. Also, this should have been homework, and this should have been grade. Forgot to adjust that. Okay. Alrighty. Alright, so we're done with 20 like we said. Okay. Now let's jump to the calculator and take a look at number 21. Take a look at absences versus grades. So looking at this, notice there's our previous document from what we did. But because there was so much data on this, I already had it, which if you did this in class, I sent this out to you. If you didn't do it in class, then I guess I'll hurry and scroll through here. So you can see that we did have a bunch of data here. And so this was the number of absences from third term for all my classes with the grades associated with that. So there's quite a few numbers, aren't there, you can see. Okay. If we keep going, I think, there we go, about 104. All right, anyway, going back up to the top. So we need to find the correlational coefficient. So menu, statistics, stat calculation, linear regression. Choose absences for x, and for the grade y, hit OK. That gives me my line of best fit if I wanted it right then. But my correlational coefficient there is negative 0.4429. So very weak. Well, pretty close to strong, but a weaker correlation in this one. Okay. So what does that tell us about the connection between absences and your overall grade? That the absences have some effect, but very little. Okay, not as strong as we would think. Now, if we go to the scatter plot, this is not the scatter plot, so I click down here and add absences for X, and then grade for Y. Okay, we see that scatter plot on our paper. And then we need to find our line of best fit, okay, which we're going to use to help us predict our grade. So I go Menu, Analyze, Regression, and Show Linear. Okay, there's my equation, and there's our line of best fit. So if I wanted to, there's my equation, I can write that on part E. Back to part A, what if I miss 10 days? Well, if I miss 10 days, it's right about there, right? That's going to be pretty close to 60. Okay, so I could kind of use that to estimate, or I could add that calculator, right, and use that line of best fit. So negative 2.187 18768 times X. Our X here is 10, because we said 10 days, 10 absences, plus 82.9188, right? Yep. Hit enter, and yeah, so 61%. Okay, so we would predict a 61% on that. Now, the last part has that residual plot. Remember, to get to that, I go Menu, number 4, Analyze, down to Residual, and Show Residual Plot. Okay, then down there on the bottom, we show that residual plot, and we see that it's pretty random, but it has some symmetry to it, a little bit of shape, but not much. So this would be a pretty decent line of best fit. Okay. In contrast, if I were to create my own, we can see right here. Okay, that definitely has a pattern of going down and to the right. Okay, that's bad because this line of best fit, this new one, is not good. Okay, if everything was above it, it's too high. If everything's below it, too low. Okay, and so using kind of that residual, you could honestly try to create your own line of best fit based off of trying to get it more symmetrical and even, yet still random. Okay, so that's what we can use to talk about that line of best fit. So let's go get this all written down. Okay, so we're back now from that last one. So correlational coefficient we found was R equals negative 0.44, so a weak negative. Okay, what does that tell us about the connection? Well, there is a slight correlation. Okay, if I'm more absent, it's gonna be, more absences, generally speaking, lower grade. Not always true. That's what the weak negative tells us. It's not always true. If it was like negative 0.9, it would basically be that's exactly what would happen. Okay, so we had our line of best fit, and it looked something like starting right here. Okay, something kind of like that. Just sketching it by hand, so yours may look a little different. And the equation was y equals negative 2.18768x plus 82.9188, which we used, and we plugged 10 in for x, and we came up with you should have about a 61% if you miss 10 days. So kind of like if you're just trying to pass the class, how many days could you miss? Well, you could miss at least 10 and you should still pass. Okay, which, speaking of, my line of best fit is a little too low, isn't it? Because this was like right here, this point, and then 81 or 82 like right there. So probably looked more like that, which was a better one. Which then, let's see, did I answer all those? Yep. Then we go to part G, okay, looking at how did our line of best fit here stack up according to the residual plot. And we see that it is pretty randomized, a lot above and below, kind of some outlier-y looking guys out here. But overall, this tells us that, our regression line, our line of best fit, is really the best way to average, the information. Okay? Something along the lines, it's a good line of best fit, essentially. Okay? Alright, guys. So, there we go. That's all of it. Hopefully you are ready for that test and you can rock star it up, right? Okay, we'll call that good then.